Dear students, before starting with session 2, let's recap rational numbers as done in the previous session. A number r is called a rational number if it can be written in the form p by q, where p and q are integers and q is not equal to 0. Every natural number is a rational number, but the vice versa is not always true. Every whole number is a rational number, but the vice versa is not always true. A number whose decimal expansion is terminating or non-terminating, recurring, is rational. A number whose decimal expansion is non-terminating, non-recurring, is irrational. Objectives of session 2. After studying this lesson, students, you will be able to perform fundamental operations on real numbers, represent root n geometrically, understand identities related to square roots, rationalize the denominator, understand the laws of exponents for real numbers. Students, as we know, decimal numbers that continues endlessly with no group of digits repeating endlessly are non-terminating, non-recurring decimals. Such numbers are called irrational numbers. Now, let us understand the concept properly by solving some questions. Check whether the given numbers are irrational or not. First one is 7 root 5, which can be written as 7 into 2.236 and so on, which gives us 15.652 and so on. Can you tell whether it is terminating or non-terminating decimal? Now, here we can observe that the decimal expansion is a non-terminating and non-recurring decimal. Therefore, it is an irrational number. Let us take one more example, that is 21 plus root 2, which can be written as 21 plus 1.414 and so on. After adding, we get 22.414 and so on. Do you think it is a rational number? No, it is also an irrational number. Similarly, we see pi minus 2. It gives us 1.141 and so on. This is also an irrational number as it is a non-terminating, non-recurring decimal. Hope students, you have understood the concept of irrational numbers. Students, in your earlier classes, you all must have learnt that rational numbers satisfy closure, commutative, associative and distributive laws for addition and multiplication. It turns out that irrational numbers also satisfy commutative, associative and distributive laws for addition and multiplication. However, the sum, the difference, quotient and product of irrational numbers are not always irrational. To understand it, let us perform few fundamental operations such as addition, subtraction, multiplication and division on irrational numbers. Students, let us start with the addition of irrational numbers. On adding two irrational numbers, we must get a rational or an irrational number? Let us make this more clear by taking an example. On adding 2 and root 3 and 5 plus root 3, we get 2 plus 5 equals to 7 and root 3 plus root 3 equals to 2 root 3. That is 7 plus 2 root 3, that is an irrational number. Now, consider another example. If we add 2 plus root 3 and 2 minus root 3, root 3 will be cancelled by root 3 and we get 2 plus 2, that is equals to 4, which is a rational number. Hence, from the above examples, we concluded that on adding two irrational numbers, we get an irrational or a rational number. Now, let us observe what happens if we subtract two irrational numbers. 2 plus root 3 minus bracket starts 5 plus root 3 bracket close gives us minus 3. It is a rational number. Let us consider another example. 2 plus root 3 minus 2 plus root 3 gives us 2 root 3. It is an irrational number. Again, we concluded that on subtracting an irrational number from an irrational number, we may get an irrational number or a rational number. Let us understand multiplication of irrational numbers with the help of examples. Before understanding this example, we must know that root n into root n gives us n. That is, root 3 into root 3 gives us 3. Now, if we multiply 2 root 3 by root 3, we get 2 into 3. That is equals to 6, which is a rational number. Same way, let us multiply 2 root 3 and root 2. We get 2 root 6, which is an irrational number. Students, after observing addition, subtraction and multiplication of irrational numbers, let us observe division of irrational numbers. On dividing root 12 by root 3, root 12 can be written as 2 root 3. So, the question becomes 2 root 3 divided by root 3. Root 3 will be cancelled by root 3 and finally you will get 2, which is a rational number. To understand it more precisely, let's take one more example. On dividing root 15 by 5, what we will get? Root 3, which is an irrational number. Before moving on to the next topic of today's session, let's summarize the operations on irrational numbers. Finally, we have concluded that adding, subtracting, multiplying or dividing two irrational numbers, the result may be rational or irrational. Now, students, quickly move on to the next topic of today's session, that is representation of root n for any given positive real number n geometrically. To understand this, let us find it for n equals to 3.5. That is, we find root 3.5 geometrically. Step 1. Mark the distance 3.5 unit from a fixed point A on a given line to obtain a point B, such that AB equals 3.5 units. Step 2. From B, mark a distance 1 unit and mark a point, new point C. In the next step, find the midpoint of AC and mark it as O. Then, draw a semicircle with center O and radius OC. After that, draw a line perpendicular to AC, passing through B and intersecting the semicircle at D. Then, BD is equals to root 3.5. After that, draw an arc with center B and radius BD, which intersect the number line at point E. Thus, E represent root 3.5. Students, notice that the triangle OBD is a right angle triangle. So, by using Pythagoras theorem, we can find BD equals to root 3.5. We now list some identities relating to square root. Students, you are already familiar with some of these from your earlier classes. Students, note them down in your notebook. Root AB equals root A into root B. Second, root A upon B is equals to root A upon root B. Third one, root A plus root B into root A minus root B is equals to A minus B. Fourth one, children, A plus root B into A minus root B equals A square minus B. Fifth one, root A plus root B into root C plus root D equals root AC plus root AD plus root BC plus root BD. Now, the last one, that is root A plus root B whole square equals to A plus 2 root AB plus B. These are very useful in various ways. Let us use these identities in simplifying some of the questions. Simplify 5 plus root 5 into 5 minus root 5. On using the identity A plus root B into A minus root B gives out A square minus B. We get 20. To understand it more precisely, let us take one more example. Root 3 plus root 7 whole square. On using identity root A plus root B whole square gives out A plus 2 root AB plus B. On simplifying, we get 3 plus 2 root 21 plus 7. Further, on adding 3 plus 2 root 21 plus 7, we get 10 plus 2 root 21. Now, let's take another example based on another identity. Simplify root 11 minus root 7 into root 11 plus root 7. Using the identity root A plus root B into root A minus root B gives out A minus B. I hope similar identities you must have observed in your previous class. On solving the given question, we get under root 11 square minus root 7 square, which gives us 11 minus 7, that is equal to 4. Students, now let us take another important and interesting topic, that is rationalization of the denominator. To make the denominator into a rational number. Before starting, we all must know that root 2 into root 2 gives us 2, which is a rational number. For example, to rationalize the denominator of 1 by root 2, we multiply by root 2 upon root 2. It gives us 1. On solving, we get root 2 by 2. Now students, let us understand the same concept by taking another example, which is rationalize the denominator of 1 by 2 plus root 3. On multiplying and dividing by 1 by 2 plus root 3 by 2 minus root 3, we get 1 by 2 plus root 3 into 2 minus root 3 upon 2 minus root 3, which gives us 2 minus root 3. Our next topic is laws of exponent for real numbers. First one is a raised to the power m into a raised to the power n gives us a raised to the power m plus n. Here students, remember that a is called the base and m and n are the exponents. In the first formula, you all must have seen that the base is same. On multiplying two exponents with same base, the powers are added. Second is a raised to the power m into a raised to the power n gives us a raised to the power mn. Third one is a raised to the power m upon a raised to the power n gives us a raised to the power m minus n, where m is greater than n. A raised to the power m into b raised to the power m gives us ab raised to the power m. In this, you all must have observed that the power is same, but the base is different. To understand these identities in a better way, we will solve few questions. First one is 2 raised to the power 2 by 3 into 2 raised to the power 1 by 3. In this question, you can observe that the base is the same, that is 2. On adding the powers 2 by 3 and 1 by 3, we get 3 by 3, which is equal to 1. Finally, we get 2 raised to the power 1, which is equals to 2. Let us take one more question. 3 raised to the power 1 by 5 into 4. Here we can use the identity a raised to the power m into n gives us a raised to the power mn. 3 raised to the power 1 by 5 into 4 gives us 3 raised to the power 4 by 5. Finally, let us summarize whatever we have learnt in today's session. Firstly, the decimal expansion of the rational number is terminating or non-terminating recurring. Second, a number whose decimal expansion is terminating or non-terminating recurring is a rational number. If we add, subtract, multiply or divide two irrationals. The result may be rational or irrational. To rationalize the denominator of 1 by root a plus b, we multiply this by root a minus b upon root a minus b, where a and b are integers. Next is to represent irrational numbers geometrically. Then let a greater than 0 be a real number and p and q be rational numbers. Then a raised to the power m into a raised to power n gives us a raised to power m plus n. Second, a raised to the power m into n gives us a raised to the power mn. Thirdly, a raised to power m upon a raised to power n gives us a raised to power m minus n, where m is greater than n. Fourth one, a raised to the power m into b raised to the power m gives us ab raised to the power m. Now let us give some homework questions. First one is, classify the following numbers as rational or irrational. First one is root 23. Second one, root 225. Third one, 0.3796. Fourth, 7.47878 and so on. Fifth one, 1.101, 001, 0001, 00001 and so on. Now, the next question is, simplify the following as irrational numbers. The first one is done for you. 12 root 3 plus 5 root 3 minus 7 root 3. If we take root 3 common, we get 12 plus 5 minus 7, that is equals to 10 root 3. Second one is 3 root 2 minus 2 root 8 plus 7 root 2. Third one, 3 root 2 into 2 root 3 into 5 root 6. Fourth one, root 8 into 3 root 2 into 6 root 2 divided by 36 root 2. Now we come on to the next question, that is question number 3. Represent root 9.3 on the number line. Fourth one is, rationalize the denominator of 1 by root 7. Second part, 1 by root 5 plus root 2. Now we come on to question number 5, that is simplify. First part, 2 raised to power 2 by 3 into 2 raised to power 1 by 5. Second part, 1 by 3 cube whole power 7. Third part, 11 raised to power 1 by 2 upon 11 raised to power 1 by 4. Thank you students. Hope you enjoyed and understood the session very well.